Good morning, everyone, and thank you for having me here. My name is Janne Elo. I'm a HPC Engineer and EBI UK. I'm going to talk quickly a little bit about how we're optimizing HPC utilization at EBI with the HPCNow metrics. The ones who don't know what EBI, what we do and who we are, we're one of the 6 sites of a European molecular biology laboratory. We are not-for-profit research organization funded by 20 member states. And at EBI, we focus on bioinformatics and big data for life science. We manage over 40 open data resources used regularly over 40 million scientists around the world. At the moment, we employ roughly just under 800 people over 70 countries. Our EBI HPC numbers a little bit. We got roughly 390 petabytes of raw data storage. Over 40 service teams. Each service team has roughly 10 to 15 people working on them. 457 physical compute nodes. And our Slurm cluster we implemented in late 2022, but most of the jobs has from 2023 beginning, and at the moment we over 67 million completed jobs in our HPC cluster. We got just under 22,000 CPU cores, 62 GPUs, and our regular average day we got roughly 107 million requests to our research websites on average day. From 41 million unique IP addresses, roughly those, we got multiple storage solutions to support our cluster. And our monitoring at EBI. So HPC cluster plays a key role in in EBI and is deeply embedded into research activities. Monitoring the HPC cluster is a business critical task necessary to prevent disruption in performance, in service and activities. As we all know, HPC cluster are complex research systems or tools. It's not a laptop, and due to a variety of hardware and softwares. To make HPC cluster run smoothly is a bit of a challenge because it's complicated. Increasing demand at EBI, at least in our one and a container-based workloads. And the importance of monitoring. So slow and unstable HPC cluster infrastructure will lead inefficiency, unsatisfied users, and a loss of reputation of institution and investments. Monitoring the cluster performance is important as it helps us to determine the efficiency of our HPC jobs and identify the improvements of area of improvements. It makes it possible to catch mistakes early, and it benefits, and that benefits for the users and a EBI as a whole institution. It provides a feedback to the users, not only as a sysadmins and HPC engineers like me, and where we can improve the users' workloads. And it also allows, as a EBI institution, to project the future investments for the clusters and other areas. And without the visibility, you cannot gain the insight of the users, and that can lead to issues and which cannot be localized or mitigated. And users often want to know how they can do their job better or improve their job scripts in order to reduce the time to result. Performance monitoring is beneficial to both, like I said earlier, for work environment and for the user and overall performance as a EBI, as a world-leading research institution. So detailed and comprehensive monitoring system or solution holds a very big central role for future usage efficiency of a EBI HPC cluster. HPCNow offers comprehensive monitoring system for us. They give a very useful and important insight, oversight about cluster utilization and job performance. Here we can see our software stack, how that we implemented the HPCNow monitoring. So there we have all the physical compute node has Prometheus exported installed, and in our Slurm controllers we got epilogues and scripts, cron job scripts running. That will push and pull for the exporters will pull for the Prometheus servers. We have 3 virtual machines which serves all these, and the HPCNow agents will push for the Elasticsearch, and we got shared NFS storage. And in the front end, we got Grafana to visualizing the gathered data. What we can monitoring with the HPCNow monitoring solution, we can get the as a cluster status for the whole Slurm job efficiencies, GPU accounting and efficiency, hardware monitoring, and job profiling as well. Here we can see I've got a bit more details on what we can see from the Grafana front-end dashboard. We can see here as a cluster status how long the job is in a bending state in cluster. So minimum waiting time, average waiting time, and a maximum waiting time. That tells how long the job is in a bending state in the cluster before it runs. And this is based in last 2 days. Okay. In here we can see the CPU time per partition. We can see how much how the jobs are distributed in the different partitions based on CPU time. And here we can see the standard. We got partitions. We got standard, short, and production, and one special partitions, and how they are utilized, distributed. In this one, we can see, based on the last 2 days, how many jobs has been completed, how many CPU hours has been delivered, and what's the CPU global efficiency based on the last 2 days of the users. 27% is not where we're aiming higher. This will identify the trends of the cluster, how we all are utilized. And here we can see the job efficiencies based on a CPU. As we can see, the graph trend goes pretty low. Obviously, we all want it to be up there to 100%, close enough. Then we are knowing that we are utilizing the cluster. That was based on 24 hours, by the way. Here we can see the job efficiencies of users. We can users with the underused memory globally. On the yellow area, we can see the user has 4 terabytes of underused memory. So then we can see the maximum underused memory per job and a user. And then we have, in the end, users with a more underused CPU time. If you use this data with the job completion status, complete, failed, timeout, or cancelled, it will give good understanding of a user's HPC research usage. And here we can see typical one easy script for users. It's been requested 8 CPUs per task and a 64 gigabyte of memory. And here we can see what's been used, memory efficiency. In these kind of cases, we would contact the users and trying to understand and help to utilize the script a bit more better, so we can get the memory efficiency and CPU efficiency better. That will help everyone to optimize the cluster. And here we can see the GPU accounting and efficiency, same GPU time per user and the GPU time per account. This shows us who's the biggest GPU user based on GPU time, and that helps us to again optimize the GPU usage. And here we can see GPU accounting and efficiency again. GPU time per job state and a GPU time lost in unsuccessful jobs. You can see roughly 76% of one of the users has lost the GPU time, and that's off from some other user. We can see the underused GPU time per user, underused GPU memory per user, and underused GPU time per account. This shows and gives us a good understanding how GPU time and memory are utilized in our HPC cluster. And here's in a slightly different graphical ways to show the GPU counting and efficiency. There's a number of GPUs and a job average GPU efficiency, which is on the top one, 97% just over, which is pretty good. So in summary, HPCNow has provided us an invaluable monitoring tool tailored for our needs and the EBI. It benefits for not just for the cluster administrators, HPC Engineer, but that goes for the users as well. So we can pinpoint the potential bottlenecks before they rise, and that can proactively engage with the users, helping them to optimize their script more efficient job. And as a result, that will help us to run the HPC cluster more efficiently, and give more potential for our cluster. HPCNow also gives us the identification if there's any hardware problems, and so we can identify them quickly and fix them and put them back into the production. So that gives us more efficient HPC cluster as well. There are a few nice to have features which we'd like to have is at some point to share these dashboards or efficiency per user. So user could go and see their own efficient jobs. But at the moment, I believe there's a bit of a Grafana side needs to find a solution for that. But hopefully we can get there, and that would give amazing insight. So we don't need to contact necessarily the users that much, which is off from our workload. They could go and see how their jobs are running and make it more efficient. And thank you very much. That's me. If you have any questions, please do ask.
Thank you for your nice presentation, also for promoting the things that we did.
You're welcome.
Now.
You're welcome.
Yes, we have a question from the audience.
Hi, I have actually a couple of questions. The first one is somehow related to the discussion we had yesterday with the panel on the efficiency and the consciousness of users of how the resources are used. So my first question is this monitoring anyhow useful for the users so that they can realize of how the resources are utilized from their perspective? I mean, it's helpful for the users themselves.
Of course, yeah. So that gives us a very good insight of the user's job script and how it's been run. So we can show them, okay, the output file might not give them exactly what has happened and how it has happened. So we can go back to the users, tell the users, this is how your job was running. Is there any way we can help to optimize your script? And because sometimes the users they inherit some legacy jobs and they just, because it works, they run it. But it don't mean that is efficient, is using the resources right. So that way we can always give the insight or see the insight and what was actually happening, and get back to the users.
Okay, that links with the discussion we had yesterday of how to educate users.
Absolutely.
So that they are aware of how to use the.
Absolutely. It's not
efficient
like we go in there and telling that you are doing your job wrong. No, that's not our
No,
mission.
you must be positive.
But yeah, we go there. Well, okay, you might inherited that legacy script or job from years ago. You know, can we somehow help them? Do you know how it runs? And that makes everyone happy, and that makes their job easier because they realizing that their job will run quicker and faster, and they can run sometimes hundreds of thousands of small jobs, but then we're throttling because on efficiency. But yeah, 100%.
Okay, and my second question is related to storage. So you have mentioned you have almost 400 petabytes or so of storage distributed in several storage silos or systems. I don't know how to call them, because I'm interested in knowing how do you manage to move data between all those silos, because in my perspective, there's a job that needs to somehow be monitored, which consists of the preparation of the data before the job can even be queued in the system. So how do you manage that challenge, or what's the impact of having different silos, and whether you are implementing a certain metric to measure that effort?
So we got several storage systems. For some are long-term storages, which we use the data movers specifically for those jobs as a long one, depending what you're going to do with the data. Then we got obviously home's got own. We got fast storage. Long-term, like I said, long-term storage solution, which we move the data to there to stay in case we need it. But as a monitoring the storage, that's a different departments. Like I say, the storage team will monitoring that and see what's the best way to move the data.
Okay, what kind of data movers are you using?
We got own just a normal compute node, which is dedicated just for data moving without memory usage and ANA.
Okay, thank you.
Thank you.
Any other question from the audience? Jordi has one.
Have another microphone in the other hand so you can answer it.
So the efficiency that you show before, around the 20-something%, we have seen an effect of So I mean, in some institutions where we see a lot of HTC workloads, where you have heaps of jobs, very, very short jobs.
Yes.
The efficiency of the cluster, the real efficiency of the cluster gets hidden because of the average. So
that's right.
That's the nature of the average.
Yeah.
Maybe replicating the same dashboard by removing all the jobs that are under 5 minutes, for example, will give you a very different metric.
Yeah.
So we have been exploring that option as well.
Okay.
Because the average hides a lot of information.
Yeah. Because some jobs what users run are tiny little jobs, but there's hundreds of thousands hundreds of thousands can be that. So those jobs run so quickly that the Slurm don't actually register them as a CPU time usage. So that gives a good indication, very good, but obviously is hidden off, like you said.
But just coming back to our last question, presumably you also have metrics of CPU efficiency that's not coming through Slurm, right? Just directly off the OS.
As a hardware CPU usage.
Yeah, just and that will give you a rather different picture. Is that what you're saying? Yeah.
Yeah. So this is based on a job.
So that's a Slurm graph rather than a CPU.
Yeah. So see, then hardware monitoring is a separate where we can see the CPU usage and efficiency there. Yeah.
Any other question? So besides the nice to have thing that you show in the presentation, that is the access tool for the users, that is something that we are currently working on it. We have to modify Grafana, as you say. It's not as easy as put just a comment.
Yeah.
We are working on that. Do you have any other request that you want to see in the dashboards?
Not at the moment. I'm sure they will come up. We only been using it, as we can see, we're trying to get that level higher. So once we using it a bit more efficiently, hopefully there's more features we might need. And one good one, what I haven't shown here actually is a cost wise. So we can, based on the CPU time and usage, we can convert that as a use cost wise, how much it would cost. But we don't want to go too much of the details because that don't include everything yet at the moment. What we can have, cost wise, is only energy usage wise and CPU time. But yeah.
Okay, thank you. So there is no more question. Let's thank again to the speaker.
Thank you.